Welcome to Chapter 1, Lesson 1.6, Represent Functions as Rules and Tables. In this first example, we are going to identify the domain and range of a function. The input-output table shows the cost of various amounts of regular unleaded gas from the same pump. Identify the domain and range of the function. The input is the gallons of gas. The output is the amount in dollars that you are going to pay. So in this table, you see that 10 gallons of gas will cost $19.99. 12 gallons of gas is $23.99. 13 gallons of gas is $25.99. And 17 gallons of gas is $33.98. So the domain value are the input values. So that would be 10, 12, 13, and 17. The range is a set of the output, which is the dollar amount that you will pay. So the range is a set of outputs: $19.99, $23.99, $25.99, $33.98. Guided practice for example 1. Number 1, identify the domain and range of the function. So the domain is always the input values. So in this example, the domain will be 0, 1, 2, and 4. The range will always be the output values: 5, 2, 2 again, and 1. Since the 2 repeats, you only have to state it once. Identifying a function. Tell whether the pairing is a function. So this is considered a mapping of the input and output. The arrows indicate the pairing. So in this example, 0 is paired with 2 and with 3. The number 5 is paired with 4, and the number 10 is paired with 5. So if it wasn't labeled for you, it is always implied that the input is pointing to the output. So this pairing is not a function. In order to be a function, there has to be a unique input for every output. So meaning the input values cannot repeat. So in this example, 0 is being shared between 2 and 3. So you cannot share x values or input values. So this is not a function. Let's do another example. Looking at this example, you want to look at the input values. If there are any input values that repeat, you will not have a function. Since this table has all unique values in the input column, then this is a function. The pairing is a function because each input is paired with exactly one output. Tell whether the pairing is a function. So in our input, which is our domain, we have 3, 6, 9, and 12. Since none of the numbers repeat, we do have a function. It's okay that you have a repeat in the output. That does not define whether it's a function or not. It's only the input values, the x values, or the domains, which all mean the same thing. In this pairing, we have output of 2, 2, 4, and 7. Notice that the 2 is paired with 0 and with 1. So this is not a function. The domain of the function y equals 2x is 0, 2, 5, 7, and 8. Make a table for the function, then identify the range of the function. So we want to start the table with putting in the given domain, the 0, 2, 5, 7, and 8 as our x values, and then plug those values into our equation and evaluate for y. So when I plug 2 in, when I plug 0 in, 2 times 0 is 0. When I plug 2 in, I get 4. When I plug 5 in, I get 10. When I plug 7 in, I get 14. And when I plug 8 in, I get 16. So my range, or my output values, are 0, 4, 10, 14, and 16. Next, we're going to learn how to write a rule for the function. Given the table, we will let x be the input, or our independent variable, and let y be the output, or the dependent variable. Notice that each output is 2 more than the corresponding input. So a rule for this function is y equals x plus 2. Write a function for a real-world situation. Concert tickets. You are buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. Identify the independent and dependent variables. Then identify the domain and range of the function. So the first thing you want to do is to write a verbal model. Then write a function rule. Let n represent the number of tickets purchased and a represent the amount spent in dollars. So the amount spent in dollars is equal to the cost per ticket times the number of tickets purchased. So our equation is a equals 15n. So in this equation, the amount spent is dependent on the number of tickets that you bought. So n is the independent variable and a is the dependent variable. Because you can buy up to 6 tickets, the domain of the function is 0, 1, 2, 3, 4, 5, and 6. Make a table to identify the range. So n is the number of tickets that you can buy, and a is the amount in dollars. So we're going to multiply 15 times the number of tickets and get our output, or our range. So our range in this example is 0, 15, 30, 45, 60, 75, and 90. Number 4, make a table for the function y equals x minus 5 with domain 10, 12, 15, 18, and 29. Then identify the range of the function. Okay, so what you want to do we're going to put in our domain values. And then plug it into our function to evaluate for y. So 10 minus 5 is 5. 12 minus 5 is 7. 15 minus 5 is 10. 18 minus 5 is 13. And 29 minus 5 is 24. So our range for this function is 5, 7, 10, 13, and 24. Last example. Write a rule for the function, identify the domain and range. So notice that the time in hours is increasing by 1. Notice that the output, or the pay in dollars, is increasing by 8. So when you notice this, we want to look to see the comparison between the time and the pay. Notice that time in 1 hour, you get paid $8. When you work 2 hours, you get paid $16. When you work 3 hours, you get paid $24. When you work 4 hours, you get $32. So what that means is your time in hours is being multiplied by 8 to get your output. So your function is going to say y equals 8x, 8 times x, because your input is 8, your output is 8 times your input. So your domain in this example are your values 1, 2, 3, and 4. Your range values are 8, 16, 24, and 32. This concludes our lesson.